Greetings, this is Mrs. Gillihan again, and we are still working on task 1.5 from the MVP curriculum. We are working currently on the Go section of our homework, which here are our instructions. Below you are given various types of information. Write the recursive and explicit functions for each arithmetic sequence. Finally, graph each sequence, making sure you clearly label your axes. And once again, let's go over a couple of tips here. Very important to make sure that you choose the appropriate independent versus dependent variable for your x and y axis. We always, in a sequence such as this, we call the terms, we assign them numbers. So the first term is term number 1, the second term is term number 2, and the third term is term number 3, etc. And those values, 1, 2, 3, those are our independent variable, and they are then placed on the x-axis. So it is very important to, I've had some students get those mixed up, and I just want to make sure you always remember that the term number goes on the x-axis when we're talking about sequences. Likewise then, the term value, which in this case our first term is valued 2, second term 4, the third term value is 6, and the fourth value is 8. And this would go on and on. So that is the dependent variable in this case, because the term value depends on the term number, on which term in the sequence it is. So that is extremely important. So let's take a look at how an appropriate graph might be set up here. Notice the x-axis is labeled as term, and we are simply labeling this as term number 1, term number 2, term number 3, term number, etc. And the y-axis is labeled with the term value. And in this case, we notice that we do have an arithmetic sequence because we have a constant difference of 2. So from 2 to 4, we add 2, and then the pattern continues from 4 to 6, adding 2. From 6 to 8, we add another 2. And so we can notice that our numbers are not rising as quickly as they did on problem number 5 video that we just did. So my y-axis is currently labeled just by 1s. I just chose to go by 1s. And that is an appropriate label in order to make sure that I can see the growth that is occurring here. And that is another tip that you need to remember over here, and that is to keep your scale constant. Make sure that the scale that you choose is appropriate to the sequence, but is also constant, and goes up. Every tick mark goes up by the same amount. All right, so when these are plotted, you can see that they are straight lines, and we have learned in class that anytime we have an arithmetic sequence, it essentially is a linear relationship, so we should see a line on the graph formed with our points. Let's talk a little bit about our functions. Okay, our recursive function here, remember a recursive function always has 2 lines. And the very first line simply tells the reader and communicates, well, what's the first number in your sequence? And that's why we use the notation f of 1, because the first term in the sequence is 2. And we just simply communicate that in mathematical form. For the second part of our recursive function, we have to tell the reader how quickly is this particular sequence growing? Well, once I have the first term 2, what do I have to do to that first term each time? So this says, well, for any old term n, okay, we have to take the term before it, n minus 1. So look to the left, to the previous term, and the pattern in this case, the common difference is 2, so we have to add 2 each time. So in order to find a term, you have to have the term before it with a recursive function. This becomes trouble when we are looking for perhaps the 50th term and we don't have the 49th term. So this really works well when you already have a list of terms and you're just looking for the very next term in a sequence, because it tells you just to go to the previous term and add 2. All right, now the explicit function, that's a little more user-friendly if you're looking for some random perhaps the 50th term way out in a sequence, because it can help us find any value of any term. Okay, so that's why it is just 1 line. And so if you're looking for any value n, you would start at 2, because that is where our sequence began. That's the starting term. plus, now this here is our common difference. Common difference times n minus 1. And we are working in class on where that n minus 1 comes from. And again, it is very important because there is the conceptual understanding of where this function comes from, but to have them memorized, your recursive and explicit formats, makes putting these explicit and recursive functions together based on an actual sequence, it just makes it so much more easy. And if we would want the 100th term, we could just take 100 and plug it in for n, and we could very easily calculate the value of our 100th term, and that would make it very easy. So, a couple of tips again. Determine that independent versus dependent variable. Make sure you label your x and y axis carefully. Keep your scale constant, especially on the y axis so you can see the growth accurately, and memorize those formulas.